did it wrong. All right, so I do want to start with question number 1. Unfortunately, it was the most missed question that there was because people were a little sloppy with it. First things first, I will tell you guys, when you do latitude and longitude, you're supposed to do the latitude first and then the longitude. Luckily, the people who did reverse it labeled them. So I did give credit if you did them opposite, but labeled them. So like I was always doing, you do latitude first, latitude, latitude. There's Northridge right there. Bring your line over. Northridge was dead smack on 34 north. Most people got that right. 34 degrees north. It was the longitude that was sketchy. And here, let me start you off this way. Here is 119. Right there. Here is 117 right there. Can I ask you guys, what's halfway between 117 and 119? 118, thank you. So 118 is that line right there. What do you notice about Northridge? In the middle of 118 and 119. So we know our answer then is going to be 118 to start with.
You want to pick 119?
You can't pick 119. Is it on the 119 line? No. So Northridge, here's what I do. So you could have, just, so look at that. It's right on that line. The problem was people didn't know what that line was. It's halfway between 118 and 119. So what were some good answers then? Halfway between 118 and 119, 118.5 degrees. These are labeled so west. Or the only other choice is 118 degrees. How many minutes is halfway? 30 minutes west. These were the only 2 acceptable answers. Did you put 50?
No, I just put 118.
Oh, yeah. So it wasn't on the 118. Yeah.
So if you did 118.5,
Yeah, 0.50, that should work. But if you, yeah, but was that you? Okay. Some people did, I had it all. So here's what was wrong. So you can't combine these 2 labels. So here was one wrong answer I saw. (118 degrees 5 minutes). So they were kind of trying to do 118.5. They're not equivalent. So that is telling me 5 minutes. That would have been just like right here, just a little past the 118. So that was one wrong answer I saw. Or the other most common wrong answer I saw was in 50 minutes. And this is what I thought you were getting at. So not 05, but 50. That means you forgot that halfway was not 50, but halfway is 30, just like on the clock. Then another wrong answer I kept seeing all day, which this one killed me. 18.5 degrees west. I forgot the one. I can't give you credit. I know you know what you're doing, and I know you meant to put the 1, but I can't give credit for that. Anybody got any more questions on question number 1? So I think I talked about this already, that this was just a quiz. So first of all, if you got a bad grade, you should have noticed that, yes, your grade went down, but not as much as if you got a bad grade on a test. Okay, so some people's went up. So then this must have been better than the last quiz you took. No, the same? They also may have gone up because I put lab grades in yesterday. So lab grades got averaged in with your class grade, and most people's lab grades are really high. So that could be it too. But anyway, not to downplay that you're good job on the quiz, but, or no, bad. If you got a bad grade on the quiz, then it was.
Let's just say
Okay, your lab grade probably brought your grade up then.
Yeah. let's say.
All right, let's keep going here. Oh, so what I was getting at, guys, is this was just a quiz on chapter 2. And if you've already picked up the packet like I asked you to, you should have noticed that the next packet is labeled chapter 2, part 2. The reason I'm talking about this now is this stuff is going to be on the test that we're going to have in about 2-ish weeks. So once we get through this packet, we'll have a test on both packets combined. So this is not like chapter 1 where we left chapter 1 behind and it's not going to show up again till later in the year. This time, this packet or the packet that we just finished in this quiz will be on another test. So get used to and get practicing with this. If you did bad on this quiz, that's why I made it a quiz. So it didn't kill your average. And it might be an eye opener of what you're not understanding. So keep that in mind. So that was question 1. I also want to talk about question 3. Question 3 was another highly missed question, and I know why. It was similar to a homework question that we had, but I changed the words, and that's what screwed people up. I only wanted the latitude system. I didn't say latitude and longitude. If you picked C, that's exactly what you did. This one is showing latitude. This one is showing longitude. So if you picked C, that's probably what you did. The correct one that shows latitude for both of them is answer B. Latitude, they are flat and parallel to each other. So looking at them from the equator, you'll see the lines going straight across the earth. And looking from the poles, you would see that they circle the earth in nice parallel lines. All right, you guys asked me to go over 11. 11, yes, this is one I was gonna go over. So I know we even talked about this on Wednesday. I talked about the shape of the earth. You talked about it that day I was absent too. I think that was last Wednesday. And we talked about it just the other day. I compared the shape of the earth to a pizza. So remember how I said you take a ball of pizza dough and you throw it in the air and spin it. And what does that spinning do to the ball of the pizza? It makes it go from being a ball to flatten out, a flattened out circle. The same thing is happening with the globe, is that when it's spinning, it's kind of doing what the pizza dough does, and it's getting shorter, just like the pizza is super short, right? It's only about this thick and really wide. That's what's happening here. We're not made out of pizza dough, so we're not going to end up looking like a pizza, but it is getting shorter at the poles, fatter at the equator. So 11 was a wording problem. So compared to the circumference at the equator, so the equator's fat, their circumference at the earth through the poles is going to be shorter, so it's going to be smaller. It wanted to know about what the circumference is at the poles, and it will be shorter at the poles. The earth is fatter than it is tall. Okay? So like it. But do you get it? It was poorly worded. In fact, when I read it during second period, I'm like, oh shoot, I hope I didn't screw this one up on the answer key. I double checked. I did not. So it is slightly fatter than it is tall, and it was asking about how tall it was. So any more questions? Which other ones do you want me to go over? There should be a couple more, I'd say.
Oh, wow.
The very last one, which was that, is it the same kind of question?
Oh, yeah.
Yep. So that's almost the exact same question as number 11. Again, just worded differently. It says measurements taken from space show the earth to be. Again, it should be slightly shorter than it is fatter. So it's going to have its greatest diameter at the equator because it's fatter than it is tall. It's not a perfect sphere. Can I ask which one you picked? B. So yeah, you had that opposite. It's going to be a little shorter than it is fat, just like a pizza. A pizza is way shorter than it is fat, but again, we're not made out of pizza. What other ones? There should be some more. Did I give you this, Chris? I had it. What did I do with it? Just had it. Guys, find me a couple more to go over.
You're the only one thing I want.
You're the only one? What did I do with this? I had them all in my hand. Yeah, when there's only 20 questions, each question is worth 5 points each then. Or 4 points each, sorry. 5. All right, you guys really no more? Okay. As long as I have this out, want to talk about number 6. Way more people got number 6 wrong than I was hoping, because number 6 was straight off the reference table. The 2 elements that make up the largest percentage by mass of the Earth's crust are oxygen and what else? So you needed this reference table. It tells you by mass. So you're looking at this one. They tell you it is oxygen, and they want to know what other element, which other element makes up the most. Yeah, right there, silicon. It's way more than anything else. So that was just looking on the reference table. This whole, I don't think there was a single, there might've been a couple questions. I mean, you didn't really need your reference table for that one, but almost every question you needed to use your reference table for this test quiz. Let me see, since you guys aren't volunteering anymore. Phoenix, tell me one you got wrong that we didn't already go over.
I got 100.
You didn't. Oh, okay. So what one? 10? Is that what you said? 10. Yep. 10. 10 was another one a bunch of people got wrong, even though, guys, question number 10 was a homework question. And I said, expect to see this on the next quiz, test, and anything else I ever grade. This one was on a homework, and I specifically told you to remember it. And here's what I had you do. Remember the crust, which is the lithosphere, is made out of rocks. The hydrosphere is made out of water. The troposphere, which is the atmosphere, is made out of air. So by looking at this, if we had to rank air, rocks, and water, which one would be the most dense? So Phoenix, if I put these in a fish tank, what's going to happen to air, rocks, and water in a fish tank? Where's the rocks going to go? Let's start there. Why? Why do they sink? Because what about their density? You're killing me, dude. Big density or little density? Big density. They sink because they have a big density. So rocks, which is the lithosphere, will have a huge density. What about air bubbles in a fish tank? Where are they going to go? Why? Because they float. Why? Why? Low density. Air has a very low density. So air is going to be the least dense. So we have air, the atmosphere, least dense, lithosphere, the most dense, and hydrosphere somewhere in between. So you got rocks on the bottom, water in the middle, air bubbles on top. That's how I wanted you to approach that question. I'll tell you right now, guys, that same question is going to appear on the test in about 2 weeks. Get used to it. Got it? Any more? Dylan, give me one you got wrong. Just give me one that we haven't gone over. Not 1, not 10, not 20, not 11, not 3. Not 1, not 3. Just pick one, Dylan. Olivia, I'm going to have you pick one.
14.
Thank you. Was that so rough?
No, I know when the-
Any would have been okay. All right, so this is, I'm glad you asked about this one because we haven't gone over one like this yet. Phoenix will remind you that what do you need to know about the altitude of Polaris? It does remain the same, but altitude of Polaris is equal to your latitude. So alt equals lat. Altitude of Polaris equals your latitude. The next thing you have to remember is what the heck does altitude mean? It means how high in the sky it is. So if here's the ground, the horizon is the equivalent of the ground, and here's the star, we need to measure this angle right here. That's the one we care about. And they already even told you that. So the altitude of Polaris equals 43 degrees. So Phoenix, what else do we know is 43?
So, 1, 2,
Latitude is 43, but what the heck? There's two different latitudes of 43. Which one is it? 43 degrees north or south? Polaris is only visible in the northern hemisphere, so it's north. All right, Olivia, which one do you want? And where is it 20? Okay, then I'll pick, I want to talk about 16 and 17. So 16, what is the altitude of Polaris for the North Star above the northern horizon at for observer A? And as Phoenix has so nicely reminded us, we need to know, if we want to know how high it is, the altitude, we need to know the latitude. Remember, guys, latitude, latitude. So for A, you have to measure it flat. So you go over here and it's 10. If you had picked 90, you just picked the number that was really close to it.
yeah, that's right.
Yes, and that's why they wrote this question like that, is because they're like, kids aren't going to pay attention and they know what they're supposed to do, but they're just going to see that that number is super close. And you do have to read over and find that it was 10. Can I show you that it's also very similar in your reference table here when you're doing latitude of Messina? It's the flat one, that's 45. Longitude is that 75. So it's very similar in your reference table with this 45 and 75 as it is here with the 90 and the 10. So you do need to be careful. And then the last one that I will force you to go over is number 17. We want same time. Remember from page 7 of our reference table, same time equals same longitude. So we needed the two that had the same longitude. I like doing process of elimination. Do A and B have the same longitude? Or I'm sorry, A and C. Nope, that's same latitude. B and E, yes, they do, but I'd still double check the rest. D and E, nope, that's same latitude. And A and C, that's nothing. So only answer is B. Are you sure there's no more you want to go over? Okay, so like I said, this is a quiz. It should not have killed your average. If you do bad on every quiz we take, it will probably start to hurt it. What will kill your average if you got a low grade on it is a test. So this stuff will still show up on the test in about 2 weeks. So if you did bad, you need to figure out what you don't know, and you need to get help from Mr. D or me or Mr. Miga or Mr. Winters. Speaking of your lab, which I know I started it, I hear Mr. Winters started it, and I think Mr. Miga starting it next week, is the latitude and longitude lab. That will make sure you get help from one of us on that, especially if you did bad on this. Or if you want one of us to just check to see, did I do this right? Have us check before you turn it in. And if you did not do good, then ask us to help you. What I do not want you guys doing in lab is getting it all wrong and turning it in because you didn't ask for help. So please make sure you ask for help. All right, well then on that note, if you don't have anything, other questions, grab your new packet if you haven't already grabbed the chapter 2, part 2. We're just gonna do a few vocab words. We're not gonna kill it today.
You're welcome. Sure, that's what you-
That would drive me insane. All right, so you should already have maybe even noticed that this said chapter 2, part 2 on it. If you even look, the first page we're gonna do notes, which is, if you turn the, gotta get off that front cover, is page 24. Starting a packet on page 24 because it's not really a new packet. We're just finishing the last packet. What I found is when I combined these two packets for chapter 2 into one, people just got like panicky because it was super thick. So I, instead of doing one big packet, I do 2 small packets, but really they go together. All right, so chapter 2, we're gonna start off with, it's still about the Earth's dimensions, so shape, size, and where you're at. So we're gonna start some maps that you've probably never used before. And we're gonna start with a field. When I say field, what first are you thinking about? Land. Baseball field, football field, a field where you're growing corn, or even this little patch of grass right here, some might call a field. That is correct. It's not the only correct answer. What's another, what else does a field mean? Oh, big open areas, I said. Yep, not wrong. What else do you think of? A solar field, so a field where they're collecting solar energy. How about the field of science? Yeah, I mean, that's, yeah. Oh, it doesn't count, okay. Well, those are all true, so, but what is a field that we're gonna be using for this class? It's really just like a generic term. Do you guys know what I mean when I say generic? Basic, average, kind of like a catch-all. So like instead of talking about all the different kinds of cereal, like Cheerios, Frosted Flakes, Rice Krispies, if I just combine all of those and just say cereal, that's like a generic term. So that's what we're going to be doing here too. So a field is a generic term for anything that's being measured. So that's the first definition on page 2, or well, page 24, technically. So you guys can add that definition in. It's a generic term for whatever's being measured. So it could be, we could measure this field outside our window. We could go across the way and measure the cornfield, or we could go up to the football field and measure it. I could make a map and call this room the field, or this hallway, or this building, or even the entire Pioneer School District. It's whatever I decide as the person making the map. It's whatever I decide. In our reference table, they have one map of New York State. That was the field. There's another map of the world. That's the field. So it's whatever you want to make a map of. And on these maps, we are going to be drawing what's called ISO lines. Let's dissect this word. What does ISO lines mean? Ever heard of anything that sounds like that? ISO.
Singular 26 ISO feet.
What the heck is a 26 ISO? What's it supposed to be?
Football.
It's a football thing. And what do you do in a 26 ISO suite?
No, it's not a real thing.
It's not a real thing.
No,
Okay, what's he thinking of?
well, a sweep is like going out.
The sweep, I want the ISO part.
I thought like by yourself.
By yourself, isolating something by itself. Now, is it only one person, or is it all the people who run, or all the people who catch get isolated?
Well, it's a running play.
Never mind. Okay, 2. Is this what it feels like when I talk to you guys?
Yeah.
It is?
Yeah.
Yeah, I'm sorry. I don't mean to make you scratch your head like Phoenix and Drake just did to me. But Chris participated. I'm glad you were participating in our conversation, even though it had nothing to do with earth science, but. Anyway, give me some more ISO terms that you've ever heard. And what is, you're gonna do it again. Darn it. What is ISO in basketball? Okay, so you're separating so that they're like equally matched. Is that kind of it? Or in theory?
Calling the guy out.
Okay.
That's what I mean.
I have a feeling it's the same thing, I'm just not understanding it.
No, it's fair by vision. What's our ISO place?
Huh?
What's our ISO place?
Okay, so I do you. Okay.
What's our ISO place?
How about the math class? I've heard you go to ISO in math class.
Yeah, isolate the variable.
Isolate the variable, get all the length variables together, right? Pull out all the x's. How about an isosceles triangle? Two congruent sides. Why are you using these big words? I think you mean two of the same sides.
Yeah.
How about isometrics when you're working out? What are you doing? Yeah, I'll tell you what you're doing. You're isolating one body part. So whether you choose to do your upper body, or your lower body, your legs, whatever. There, I taught you something.
Thank you.
So moving on, I don't even know where we're going with this. So these are gonna be lines. I hope you got that part from ISO lines. They're gonna be lines that connect points of equal value. So equal, like the same. So isosceles triangles have equal sides, congruent, whatever. They have the same sides. Isometric, same body part. Isolate, you take everything that's the same and put it in one spot. So we're gonna actually be doing, have you guys ever seen a map with a bunch of lines on it?
Yeah.
Yeah.
That's what we're doing. We're gonna learn to draw them, read them, and do math with them. If you haven't seen them, don't worry, I'm about to show you a bunch of them. Oh my gosh, do you guys have those?
Yeah.
I would love one of those. Yeah, it's just like what he just said. Go ahead, what is it, Sam? And it tells you, so you can see like where, like, I'm guessing like around the road, it's not as high as in the middle of the field. Yeah, it's just like that in real life. I'm gonna definitely need one of those if you can hook me up. So yeah, it's the map that connects areas of equal production in a field. We're going to be using, we won't use one like that, but we could have, and I might make a lab about it now, but you don't have to thank Sam for that. I could have just made one out of anything, but he's going to give me a real life example. So some examples of an isoline. The first word you have there is an isotherm. So we've already decided that iso means the same. What do you think the therm part of this word is? And that means heat, temperature. So you'll see maps that can, so isotherms, next vocab, iso, same, therms, temperature. These are lines that connect areas of equal temperature. You've probably seen these maps on the weather reports. I'll show you one in a minute. Another one that you might have seen on TV would be isobars. This one's a little bit not as easy because they're not bars like where people go out and drink or something like that. These are isobars. These ones connect areas of equal barometric. So see the barometric, that's air pressure. Air pressure has a lot to do with weather. So again, the Weather Channel, the weather people, they love these things. You can do them for just about anything. This next one's not on your notes, so you don't have to write this one. You could do them for equal concentration of chemicals. There was an oil spill, now it's a long time ago. I don't even know if you guys would know about it, in the Gulf of Mexico once. Yeah. And it was, they would map out how much oil there was right near where it was spilling, and then it would get less and less and less as you'd go out. So that's one you could do. You can literally do it for anything you can measure. So how much a field is making, how much crop each part of the field is making, and make a map out of it. The Weather Channel loves these things. Here is a very basic version. You don't see these on TV too much. Looks kind of complicated and overwhelming, right? But have you seen a map that looks like this? Yeah. Now look what they did here. So if you are able to outline the outside of each one of these colors. I'll just do a few, and I know I'm not quite exactly where but now, doesn't that part that I highlighted in green kind of resemble what's going on here in the blue? So that's all these, well, I know. So here, what if I turn it so it's not, see how it's a map with a bunch of lines on it? I know it wasn't a perfect example, but all they do in these colorful ones is they have two lines and they shade it in with a color so that you don't have to like look at the actual numbers. You can just look at the colors to see what's going on. Now this is a weird map. It's a map of indoor heating and cooling forecast. Okay, so if it's in the red, it needs a lot of heat. If it's in the blue, it's getting a lot of air conditioning. It's basically a temperature map, but a little bit different spin. How about this one of my favorites? Aches and pains. What? Yeah. So they must have done a survey of who was complaining about the most aches and pains and connected all those parts that were equal, and they came up with some patterns. So you can see over here in California, they must be chilling pretty good. Us over here in the east, especially up in this northeast corner, we're complaining a lot. Florida, which I find weird, is not complaining that much about aches and pains.
That's why it's a bunch of babies.
So we're either a bunch of babies, or why might we complain more about our aches and pains than those people in Florida? Because of the weather. We might just have more of a negative thoughts than the people in Florida. I don't know if you noticed that this is from 2002. California has no aches and pains. I have my own theory on this. Of what? No, my theory is, my working theory is California was always known for their drug use. And so they just use marijuana instead. Yeah, I don't know. That's just me joking, but yeah. The bell's gonna ring in about 3 minutes. Can you just go at the end? One more set of notes. A map. And I'm taking for granted that you guys know this about a map. That a map is just a snapshot of a particular area. Whatever I choose to make a map of, that's what my map is. This last one is really important that you understand. Just because the fields end, or just because the map ends, the field keeps going. So like that map of New York State in your reference table, you know there's more to the world than just New York State, right? There is. Same with that whole aches and pains thing. Notice, is there anything going on in Canada and Mexico on this map? Does that mean they have no aches and pains? No, it doesn't. It means they didn't ask them, so they didn't put them on the map. So the map, just because the map ends does not mean the world ends. I think this looks like a good spot to stop for today. We got a couple more to go, but those will be perfect for Monday. Guys, no homework. Give a 3-day weekend. Please behave yourselves, make good choices, and don't drive your parents crazy. Yeah, it's Columbus Day, or it's Indigenous